Today I would like to present our work, which is an interdisciplinary attempt to analyze the practice of humanoid robotics in relation to the concept of time and repetition. In this work, we will refer to the humanoid robot called iCub, made by IIT Istituto Italiano di Tecnologia. I am the person you can see here, a sociologist who has conducted a participant observation in several robotic laboratories with at least one iCub. Here I am teleoperating the iCub. The other person that comes into view here is a roboticist who is a co-author of this paper. The other co-authors work on the iCub as well. Let's call all of them roboticists. We have observed the iCub from different perspectives. I myself intend to research how the iCub has been scientifically used and technologically built up. They have conducted research with or developed technological parts for the iCub. In this real-time experiment, we intended to replicate, or shall we say repeat, human motions into the iCub via the data recorded from the motion capture suit that was worn by me, which is turned into data for the iCub motion. Methodology is mostly qualitative. I observed ethnographically and participated intently in their activities. They in turn observed me and the iCub in a real-time experiment in order to evaluate how precise and robust the teleoperation was. The experiments were conducted in 2018 at INRIA in France. Therefore, the question about time and repetition emerged from this context. But what is time and repetition? The concept of repetition comes from several sources, among them the French philosopher Gilles Deleuze. In short, repetition happens in two ways. Let's call them natural repetitions and differential repetitions. For instance, if you take iCub as electromechanical repetitions of the same physical phenomena every time it works, we have natural repetitions. In turn, if we apply it to humans, the concept of natural repetitions does not work so well because humans repeat differently every time, which is known as differential repetitions. In other words, iCub moves because it repeats the same technical conditions and humans repeat differently because our social, historical, political and subjective conditions are always different. We would like to sustain that in general both the repetitions are interconnected. Let's imagine that each square is a system. From an interdisciplinary systems theory perspective, we could formulate that humans are in social systems, which means humans come from the evolution in biological systems, yet biological beings such as humans also come from physical and chemical systems. There are various systems, and these systems have their inner time, at least the social ones. Mitsuhiro Tada claims that a system is not in time, nor is it a system that first exists and then has time, but rather a system is time. Let's assume, however, that every system has its own inner time, or at least its own inner repetition. Additionally, systems come from other systems which repeat some of their inner elements, even though each new system is considered to be new because it is different from the previous ones. Let's suppose that technology from the point of view of an interdisciplinary systems theory deals with the environment, that is, with repetitive elements of physical and biological systems. Finally, let's delimit that the iCub is a technology that deals with repetitive physical elements. Before we go on, what is technology? Halfman claims, technology is a communicative mode of operation by which a set of information is linked in the medium of causality and isolated from other communications. Additionally, Halfman formulates the concept of technology based on the theory of social systems. In this way, technology is centered around the question whether or not it works for communication. If it works, we have a medium of communication among social and psychic systems. If it does not, we have an installation, which means that the technology is broken or that it is being developed. In the case of the iCub, we have an installation of a humanoid robotic technology, which in some cases work as a medium of communication in laboratory conditions. From a contextual point of view, a table, electricity, a light bulb, flat floor, etc. are all examples of technology. Having defined what technology is for our work, let's return to our experiments. As you can see, the roboticists have established here some limits so that the iCub will not fall down. I'm wearing a motion capture suit which records data from the position of my human body joints and replicates them in the joints of the iCub. To set up the experiment, the motion capture suit had to be calibrated through a software which computes the human body sensors coupled into the suit. The person who prepared the suit configuration is my colleague here. This way, an avatar-like body appears. The next step is to record my motion data because the sensors give the software the position of my body in time. So, if I move my arms, the sensors will indicate my motions, which will be recorded. Then it opens some temporal possibilities. Here are some illustrations. 1. Data are just recorded. 2. Recorded data are replicated in the simulator. 3. Recorded data are taken at the same time or in parallel as they are replicated in the simulator. 4. Recorded data are replicated in the iCub. 5. Recorded data are taken at the same time as they are replicated in the iCub. The numbers 3 and 5 are made in so-called real-time and there is a small delay between capturing data and replicating them in the simulator or iCub. There is a difference between humans and humanoid robots. That is exactly what the repetition does with both, a relationship between natural and differential repetitions. Humans rely on muscles to move, but only muscles are not enough. They need a socialization of the body in order to move coherently. That is called by Lacan, for example, the mirror stage, when an eye function will unify the chaotic body motions of the baby, but only under the condition that this baby regards the entire body of the other, who is already a coherent unity. That is a social situation. In turn, the iCub do not have muscles, it has motors. Motors in actuators represent degrees of freedom. They transform electrical into mechanical energy, resulting in motion. To sum it up, motors are usually rotary-based and have rotors and stators. Electromagnetic forces emerge from the interaction of a rotating magnetic field generated by the fixed stator, where there are 3 electric phases, and the permanent magnets curved into the moving rotor. This hardware scheme is controlled by a low-level software controller which also manages time in order to give the motors periodic electricity in repetitive patterns. The unit of time here is the millisecond. Hence, here, from the point of view of humanoid robotics, time and repetition appear at a micro-technological level. From this moment on, the code written by the roboticist will control the entire unit to accomplish motions that require the coordination of all the iCub's body parts, also called whole body motions. The code repetitively queries a mathematical optimization problem based on the dynamical model of the robot in order to generate valid torque references for the motors. The optimization problem determines how the motor's references are computed and takes into account several tasks with different degrees of priority. Now we can better formulate the interdisciplinary question of natural and differential repetition linked to time in the iCub teleoperation. Humans are placed within social systems, biological systems, and physical systems. Technology has been built up since humans created themselves. As human products, technology deals with nature, that is, biological and physical phenomena mostly, which are also underlying repetitions. iCub, as seen before, is a consequence of natural repetitions too, at a mostly physical level, but also within the framework of the human communication. The fact that the iCub moves, for example, comes also from a performative act that assigns the body motions to the iCub. Such a motion is executed by humans as a result of an evolutionary path, whereby repetition always happens differently. In humanoid robots, repetitions have to be stabilized and controlled. In the teleoperation experiment, natural and differential repetitions are temporally linked to one another.